Hello guys and welcome to the lecture revision of week 6. Myself Dhruv Janakala, I am your maths mentor and this is the page distribution table. You can go through this while accessing the PDF. Index, what the topics we are going to be covered in this lecture. First we will see what are logarithmic functions, then we will go through their graphs, then we will study natural logarithm and then some properties and we will do some questions. Before begin, let's go through the quote of the week. The logarithms of life are written in increasingly small numericals, said by Edward Lewis Walton. Let's start with the first topic, logarithmic functions. The logarithms of a number is nothing but a power or the index to which a given base must be raised to obtain a number. Let's say, as previously we have learned exponential functions, in which we can write as a to the power n is equals to b. Here you can observe that n is the exponent to which the power is raised, a is the base and b is the value to be obtained. Now if you transfer this base to this side, you will add a term known as log. Then the expression will become log a, which is the base, and the value will be kept beside the log a, which will be the value of is equals to exponent. This a gets jumped to the b side where it comes on the feet of the log, and then it becomes log b base a, which is equal to n. Going to next topic, we'll go through some of the graphs. This is the graph of log a x, log x to the base a. This is log x to the base e. This is also known as ln of x, natural logarithmics. This is the log x base 2. Here you can see three different functions graph. This is the normal x graph, which is a linear function. Then you can see here this is the log x graph, ln x graph, where base is e, and this is the exponential function of x to the power e. Let's go through the theory of logs first. Okay, so as we know that the range of function ax, which is nothing but an exponential function, is 0 to infinity. And from previous slide we have seen that log functions are inverse of the exponential functions. That's why here the range of ax is 0 to infinity. Therefore the domain of the log x to the base a will become 0 to infinity. Whatever is the range of one function becomes the domain of its inverse function, and we know that ax is inverse of log x. That's why. And now if you will calculate the domain of ax, which is r, then the range of function of log x to the base a becomes r. The y-intercept of function at this point of ax is 0, 1. Therefore when you will take log x base a, the x-intercept will become 1, 0, because its inverse input will act as output and output will act as input. Here 0 was the input and 1 was output. Here 1 will become input and 0 will become output. As you can observe here, the graphs are reversed. This is the exponential function graph and this is the log function graph. Similarly, since the exponential function didn't have any x-intercept, that's why the logarithmic function will not have any of the y-intercept. And let's see of n behavior. X goes to infinity, x goes to infinity in exponential case, and when x goes to negative infinity, the exponential function would go to 0. Here when x goes to infinity, log x will go to infinity, and when x is greater than 0, which means it can be close to 0.0 bar 1, but it cannot be equals to 0. In that case your log function will go to minus infinity. Next, you know that there was no real root of the x function because there was no x-intercept. Whereas in log function there is an exception, that since x-intercept is present and y-intercept is not there, that's why one root exists, which is x is equals to 1. The reason is because you can see this part has a root here. If ax is an increasing function, then log x would also be increasing function, and if it's a decreasing, then log x would be decreasing function, depends anything. And then here log x is also 1-to-1 function because they both are reversible. When you will reverse log x, you will get e to the power x. Moving forward to next case, this is the case. Also the base of a has similar properties as the base of the exponential functions, that it should be greater than 0 but it cannot be 1. Here we will see when the log x has a base which is between 0 and 1. The starting would be same, range and domain. Range of exponential will become domain of log, and the domain of exponential will become range of log. Y-intercept is point 0 comma 1, here x intercept will become 1 comma 0. Ax doesn't have any x intercept, therefore log doesn't have any y intercept. This is the same, these are the end behavior which we have previously discussed. Here you can see that there is no root, this part also stays the same. And then the reverse function, which is log function, will have only one root, which is at x equals to 1. And here you can see that a is the decreasing function, that's why your log x is also a decreasing function, and the log is a 1-to-1 function. It stays the same. If everything above will get opposed, only thing that remains same is that if a function is decreasing, then its reverse function is also decreasing. That's the only thing that remains same to keep in our mind. The next, here you can see that natural logarithmic functions. These are the functions where the base of log functions is e. Normally you can take any number as log functions, still is greater than 0 and not equal to 1. In this case, let's say you have taken the value of a is equals to e, then you can denote your log function by ln of e, which means natural logarithmic, and denotes natural. That's why you can write log x base e or ln x. When you let ln x, the default value of your base is to be considered as e. Also, we should keep in mind that this is an increasing function because the value of e is greater than 1, which is 2.17 something. Then the domain remains the same, which is 0 to infinity. Range will be remain the same, which is real numbers. X intercept is 1 comma 0 and y intercept is not possible. And behavior will remain same. When x tends to infinity, ln x tends to infinity. When x tends to 0, ln x tends to minus infinity. Here tends to is written, and if you have to equalize it, then it will come 0 positive, means the value should be a little more than 0. It can be very, difference will be very less between the value and the 0, but it will not be equal to 0. Then also ln x has only one intercept, giving it only one root at x equals to 1. Then the function is increasing function as previously said, and then the function remains 1-to-1 function. Moving forward, these are some logarithmic properties that you have to keep in your mind. Let's start with first property, which is the product property. In this case, let's say this term which is in bracket is called your value. Let's say you have a value that can be written in form of product of two numbers. Then you can split your logs as log, the base will be same, and then each value will get separated, and then we have to add those. Therefore log xy base b will become log xb base b plus log y base b, as you can see here. Same will go here. Ln is nothing but when the log base is equals to e, at that time the value of your log properties will become ln of xy, which will become ln of x plus ln of y. Here example is written log base 3 of 10. Here you have to see, you can see that 10 can be written as 5 into 2. Therefore you can write it log 5 base 3 and log 2 base 5 base 3. These are the two values that okay. Then comes the question property. You don't have to keep these property names in your mind, you just need to understand what the properties are. Whenever your value is in, can be divided or you can get separated. Let's say you have a 0.2 something in your value, then you can write it as 2 by 10 or 1 by 5. In that case it will become log of 1 minus log of 5 with something base given. Here as you can see, these are similar to exponents if you will notice. Example, log base 3 of 5 by 7, which can be written as log 5 base 3 minus log 7 base 3. Then comes power properties. In this case, whatever your value's power is raised to will come in front of your log. It will come front here. These are special properties only which are applied to logs. Here you can see log base b value is x to the power p, therefore p times log x base b will become. Here ln x same, and here you can see you have taken ln of 27 to, you know that 27 is the 3 cube. Therefore ln of 3 cube, which will become 3 times ln of 3. It means that when you will take the value of ln of 27 in your calculator, and if which will be equal to 3 times the value of ln of 3 when you calculate it. Then comes the root property. It's also the same. As you can see here, you can see your value is p root of them, which means that x to the power 1 by p will be there. Therefore 1 by p will come here in front of your log. Also, let's say if your base has some power, let's say your base has power of 2, means you can write that log x base 2 square. Then that 2 will also come out. If you want, you can bring it out, but in that case it will be coming as the root property, means if there is square, that will become as 1 by 2, means anything that's in the root has to be divided by the log. I will show it ahead. Then comes inverse property. Let's say base and your value is same, you can directly put it as 1. this will become 1 when you will apply the power property and bring your x in front of the log. Then you can just simplify log b base b is equals to 1, because when you have value and base as same, then they will get simplified to 1. Here you can see that ln of ex is there. When you will take x in forward, then ln of e, because base is e and the value is also e, it will get 1, so x is equals to 1. This is called the inverse property. Here you can see that 4 will come forward and base 3 and value 3 will get cancelled, making it 1. So 4 is equals to 1. 4 is equals to 4. Here is the identity property which we previously discussed. Let's say whenever your base and the value is same, then it's equals to 1 in all the cases. Then is the 0 property. If your value is taken as 1, then doesn't matter what your base is, your log will always give the value of 0. Log with any base, when value is substituted as 1, gives 0. This is the change based property. Let's say you have log x and base b. You have some value and some base. Then you can distribute it in division form by applying a common base and taking both the value and the previous base as your new values. Let's say here you want to separate this log x base b. So you can take log x and some base a and then divided by log b some base a. Here both the bases are same, if you will notice. That's how you can distribute your base. Here you can see these are mainly used when your equations are more simple. Here you can see ln x is there, so you know that when there is ln, then base is always e. Therefore you will take log x with base a and then log e with base a. Here a can be any base of your choice. The same is here. Log 6 base 5 will become log 6 with some base and log 5 with some base. Here equality property is written, which means that when your logs and bases are same and then equalified with some other logs with values, then both of those values are same. It's just like a square is equals to b square, which simply means that a is equals to b same. Here reciprocal property means that let's say you have something log of half base b. So in this case you can do the reciprocal of x raised to 1 by x raised to minus 1 will come, then that minus 1 will come forward of your log. If you recall your power property, what you have to do, we are taking the power out of the log function. In that same way, here 1 upon x will become x raised to minus 1, then minus 1 will come forward and then your log will turn negative and it will give you a reciprocal of your value. Therefore minus log b by x is how the reciprocal property is defined. So that's all the theory part. Now we will move towards the solving part. Let's solve some more questions of the exponential functions 2 of previous week extra. Then we will move forward to solving log functions. Let's begin with the first question here. Here we have to find the value of x. We have given equation as e to the power minus x square, which is equals to e to the power x raised to square divided by e cube. In this you can go by simplifying. Either way, you can give this e to the power cube at this side, or you can just go by simplifying each side. Here as you can see, they have took 2, anything raised to anything is always multiplied. E to the power x raised to 2 is written as e to the power 2x, because raised to times raised to is always multiplied, that's why. Then here you can see denominator has e to the power 3, which is then subtracted, because when bases are same and in division the bases get subtracted, powers of the base get subtracted. So that's why you will get this. Here you can apply log, or you can directly drop the bases and you will get the equation of minus x square equals to 2x minus 3, and just rearrange and simplify. You will get the value of x plus 3 and x minus 3. So your values are minus 3 and 1. Here they have simply applied ln on both the sides. You know, when you are applied log, you can apply on both the sides, then the power will, let me clear it. The power will come forward in both the cases. Then you will simply be left with ln of e and ln of e, which will be, as identity property states that they are one, so you will eventually get the same equation from this way. That's all. Then moving to the next question. In this question you have to solve this equation and find the value of x again. Here you can see this equation. For simplifying, first they have factorized it by taking x square out, then simplified it again, like 6 3x and 3x. Then they have substituted 3 to the power x as y to make the calculation simple. Then you have to solve for this equation, and it will also good if you can substitute this depending on how you need to solve. Let's say 3 to the power x can't be solved. The reason is because here 1 2 is present. Therefore, after simplifying, you will get the value of y as y minus 9 into 1, which means 9 and minus 3. Then you have to make sure that you make this equivalent to 3 to the power x. So after applying, you will get two values. One is 3 to the power x equals to 9, 3 to the power x equals to minus 3. As you know that the exponential functions are always positive as their outcome. That's why your second case will be rejected, and 3 to the power x equals to 9 is your solution, which means that 9 is nothing but 3 square. Therefore, your value of x is nothing but 2. These questions are easy, just you need to practice them. Moving forward to logarithmic functions question. First, you have to solve for the x in this case, which is 5 to the power x minus 2, and then 3 to the power 3x plus 2. In this case, the bases are different, so direct calculation won't work. Therefore, we will take some base. Here you can see that generally we prefer to take the base of 10, because normally whenever you will use your calcs, all the calcs are adjusted to the log base 10 and ln to base e. That's why you will moving forward. Same power property takes x minus 2 and 3x plus 2 out. Then you can simplify again. You can split x minus 2 with log 5 base 10 here as they have shown. Then 3x plus 2 log 3 base 10 is also separated. Then you have to change the sides and take alike terms common. Just after doing that, you will get x here common. After that, just put them in the division form. As you know that since all the bases are same, so you can just first multiply this, which will become 15, and then this will become divide 5 by 27, because this 3 will go to the power of this, and then again you can subtract it. As you can see here, they have went till this step and then they have left it here only, but you can go and write 15 minus 5 by 27 if you want to, or this answer only, depends on how the options are been given. You just need to keep on applying the properties that you have learned through this lecture. Moving forward, here we have given log x plus 1 base 8 plus log x minus 1 base 8 equals to 1. You can see that both the bases are same, so just multiply. You will eventually get x square minus 1. Then when you will send this 8 this side, here 8 will come. How? Because let's see, you have ax of x, which is equals to 1. This is log. So when this base will go here, your x will become 8 to the power 1. Whatever this is there, it will go to the exponent. It will become exponent of the base. Therefore, you will get here x square minus 1 equals to 8, which will make x square equals to 9. So the possible values are 3 or minus 3. And also we have to keep in our mind that these are the inputs of log function, and as I previously told, the inputs cannot be negative. That's why x equals to minus 3 will be dropped, and only solution is x equals to 3. Keep this in mind. Whenever you are solving for the x value which is as an input of log function, prefer to take only mod values of the x. Next, ln of x square is equals to ln x whole square. Where you can see that this 2 will come here. Ln of x square become 2 ln x, then which is ln of x whole square. Ln of x with square gets cancelled. Ln of x is equals to 2. You can say have substituted here ln as t and then solve. So you will get one value as 0 and one value of 2 of t, because you see 2t square minus 2t is equals to 0, so t equals to 0 or 2 equals to 2. So here you can see that two values are possible. Ln equals to 0 is when x is equals to 1, and ln equals to 2 if x is equals to e square. The reason is because when you will substitute e square, 2 will come front, and then ln of e means base is e and value is e, so both of them will get cancelled. So remainder will be 2. That's why. Here is our last question. Find the value of x which satisfies the equation. Here you have given log x base 3 and log x base 4, which is equals to 4. Here we will apply the base change formula. We will take both the bases as e. Here you will get ln of x, and then here ln of 3, here ln of x upon ln of 4, and this is the same 4. That's why after simplifying, it will just simply become ln of x will become 4 times ln of 3 times ln of 4 divided by ln of 12. You can simplify it if you want, or you can just skip. Then you will substitute this ln's base e this side, making it x equals to 4 times ln of 3 times ln of 4 divided by ln of 12, which is the exponent of e. So that's all. Thank you. Don't forget to like, share and subscribe.